Okay, so today we're going to talk about communications in our proof of stake demo. And we're going to use something, basically the concept of a remote procedure call. Now that could be direct called, or in our case we're going to use a message broker called RabbitMQ. So this is an example here. Good definition from tutorials point. You have clients and servers. The client is going to send a message to the server. The server is going to execute that message. Going to take the parameters that are passed with the, going to use those to execute the call and then send the result back. And it has advantages and disadvantages. It's hidden. It's kind of you just have to know the parameters. It's just like any interface, right? You have to know the interface. You don't care how it's implemented, which is kind of nice because if things change, you don't, and if it doesn't affect the connection between you and the innards, then you don't care. It's like any program that you use, if you don't care how it's implemented under the hood, you care about what you have to do to work it, what things you have to pass in, what the menu looks like, all that kind of stuff. How it's implemented behind the scenes, generally you don't care. The only time you care is if there's a bug or, let's say, in a version update, you'll care if they change the interface, but that means you have to learn something new. You have to, be aware of it and change what you're doing. Or if they make improvements to make it faster or get more capacity or whatever it may be. So the nice thing is they can be used, they're distributed. They don't care where they run. In our case, we're going to be doing this all on a local machine. We're going to be using different ports, and all these processes are going to run, and they're going to have to talk to each other. They're going to have to know when it's time to make a block. They're going to have to know to run the proof of stake algorithm, and then who's going to create the new block. The new block is created. Everyone has to get synchronized. Hence, remote procedure calls. Now, for our purposes, what I decided to use is RabbitMQ. And RabbitMQ is a message broker. So basically, you produce messages and others can consume them. You can subscribe. So using that system of producers and consumers and subscriptions, we'll be able to pass messages around through the RabbitMQ queues, message queues. So if you're a consumer, you're going to wait for a mess when the consuming part. The producing part is going to produce messages, and that's how it's all going to talk to each other. And this had 2 articles here. I think this is also on it. Is this RabbitMQ or just? Yes, another one. There are different ones. So you can do a direct fan out exchange. That's going to be more like a broadcast. I think a topic exchange. Yeah, I think a topic exchange. A fan out. Yeah. So this is what we're going to be using. Now we have a good example here. I think it's this one. Yeah. Where someone asked about it, and what I'm going to try to do over the next week is take this code that here's our server and our client, set up RabbitMQ, and see if we can get it to work. Because once we get it to work, then we can modify it and have it do what we need to do. That may mean calling the proof of stake algorithm. It could be sending transactions to, my guess is it'll be one node that's going to handle the transaction, that's going to like handle it. And there are different ways of making that distributed. It could be, one's chosen and then every so often you choose a different one. It could be local and then the different localities sync up. That's how some blockchains do it. So there are multiple ways of handling it. But the whole concept, the thing that we have to understand is the actual, how these message queues are going to work, how RabbitMQ works, and understand if you get RabbitMQ and you know how to work with it, there are other queuing systems, similar systems, ActiveMQ and all different ones, and most likely as a developer at some point you're going to need to use those for various tasks in whatever system you're working on. So anyway, so what we've gone over today is the critical communication between nodes is critical. We're going to have messages passed between them. The broker, the message broker that we're going to use for our demo is going to be RabbitMQ, which is an open source and free and all that kind of good stuff. And we're going to be able to pass messages back and forth, send a message that all the other nodes get so that they can know what they're supposed to do, and so forth. So hopefully this has been helpful. Again, next time we're going to go through this example that is presented in this Stack Overflow. And if you're not familiar with Stack Overflow and Stack Exchange are lifesavers. Because always things will come up, and this is the website that more often than not has your answer. So thank you very much for watching, and I will speak to you next time. Take care.